Hi, I'm Jake Bert, and along with Carolina Reyes, Octavio Mendoza, and Joseph Falcao, we designed and produced a fixture to manufacture a bottle opener.
Fixtures are critical tools in manufacturing. They are responsible for the quality and productivity of mass production and typically correspond to one part or a family of parts. Our objective for this project was to design, manufacture, and test a fixture that successfully position our workpiece, withstand the forces applied by the CNC milling operations, attach the work holding to the machine, and apply holding forces. Hence, we use SOLIDWORKS to design our fixture to machine a 2-operation CNC mill part. HSM works to communicate our design to the HAS VF2 CNC mill, and Mighty Byte fixture clamps to assemble our fixture. Designing our own fixture allowed us to understand the considerations that must be taken in order to increase productivity while keeping cost efficiency and safety in mind.
We wanted the design of our fixture to be relatively simple and use as little parts as possible. The specifications we had to meet include fitting a base size of 1 inch by 4.25 inches by 9.25 inches, and it also had to be mounted to a Haas VF2 CNC mill. Had to be indicated parallel to the machine's axis, hold both operations simultaneously, qualify and locate off of the datums, as well as load and unload in under a minute. Including all of those, we also had to withstand tooling forces with a safety factor of 2.0. To ensure that we have a factor of safety of 2 or greater, we included 2 clamps on each of the operations. Since we wanted to use as little parts as possible, we decided to only include 1 dowel pin in the center to locate datum A and to qualify datum A on the stock. We also used a bar to locate datum B. In order to prevent clashing, we had to recess both bars and the clamps on Op1. The cutout on the bottom is our indicating band to align with the machine's axes. We believe our simple design will allow us to load and unload quickly and will prevent errors as the parts can only fit in the fixture in their intended direction. This was done by only allowing Op2 to fit in one way. DFM influenced our design as we wanted to have very few parts, quick unload times, and pokey yokes to prevent operator error.
Once the fixture was machined, some hand deburring was required to clean off the edges. The holes used for the Mighty Byte fixture clamps had to be hand tapped and deburred as well. Once the Mighty Byte components had been assembled on the fixture, the actual testing could begin. The fixture was clamped down to the mill's table via the T-slot bolts. The first issue we came across during the machining phase of testing occurred while attempting to clamp the aluminum stock on the fixture. One of the Mighty Byte clamps would not clamp down on the aluminum block because one of the corners on the brass hexagonal washer would hit the wall of the recessed pocket. The recessed pocket did not give the clamp enough clearance to account for the washer's movement. To overcome this problem, an end-mill was used to widen the pocket. Once the recessed pocket was widened, the clamp had no issues securing the stock to the fixture. The first operation was then successfully completed with no further issues. The part could now be attached to the other side of the fixture where the second operation is to take place. In the second op, the operation was located by sliding the part up to the pin and rail. An Allen wrench was placed through the holes in the stock in order to clamp down the part to the fixture. Once the second operation was completed, the part was removed and visually inspected. Another issue did come up. The chamfer on the part was off. One side of the chamfer extended into the part while completely missing the edge on the opposite side. To resolve this, the indicator was used to locate the exact edge on the part, and the necessary distance adjustments were input into the machine. Once this adjustment was made, the second operation was successfully completed and the production of the bottle openers could begin.
This project, the parts were successfully manufactured, inspected, and tested to ensure proper functionality using these subjective observations. These results are acceptable for a preliminary design, since we were expecting to experience minor issues when manufacturing a new design for the first time. We can confirm from these results that the fixture design is in fact a good one. A few minor problems and limitations that we did come across were the fact that the fixture design did not allow enough room for the stock to cover the clamps. There was also not enough clearance for the recessed clamp, not enough clearance for the machine for both sides of the operation, and lastly, the chamfer was inconsistent on both sides of the part. And overall, this project was a success, and we were able to make parts after some minor adjustments. To sum up this project, we were given the task of designing, manufacturing, and inspecting a CNC bottle opener. The most important result was the fact that the part was successfully manufactured using the Haas CNC mill, and the fixture design that we made could be improved in the future by removing the shared dowel pin to simplify the transition from going from Operation 1 to Operation 2. In addition, the clamps could also be moved for Operation 2 so that the leftover stock from Operation 1 does not cover the clamp screws.